Hi class, welcome to section 6.2, which is systems of equations in 3 variables. In this section, you're going to have 3 equations with 3 letters. You'll have an x, a y, and a z. You do want to keep the equations stacked on top of each other, and your goal is to get the equations in the following form. ax plus by plus cz equals d. Your second equation, you want to eliminate the x and just have ey plus fz equals g. And your third equation, you want to eliminate both the x and the y, which is hz equals k. So notice as you move down, you have less and less letters. Once you have it in this form, by the way, this method is called Gaussian elimination. Once you have it in this form, you can solve for your z and then back substitute into your second equation and solve for your y, and then back substitute into your first equation and solve for your x. So just so you know, there's 3 rules that you are allowed to do. You are allowed to interchange any 3 rows that you want. You can also multiply any row that you want by a constant. And last, you are allowed to add any 2 rows together that you want. And once you add those, it will replace one of the rows that you used in the addition. So I'm going to show you 3 examples so that you can get a feel for what this method's like, and then I want you guys to attempt the homework. So if we look at our first example, our first equation is x minus 2y plus 3z equals 11. 4x plus 2y minus 3z equals 4. And 3x plus 3y minus z equals 4. So keep in mind that your goal is to eliminate the x's on both equation 2 and equation 3. So we're going to do this in 2 steps. The first thing we're going to do is we're going to take equation 1 and we're going to multiply equation 1 by a negative 4. So when we do that, we will have a negative 4x plus 8y minus 12z equals negative 44. Then we are going to add that to equation 2. So if we add straight down, we have negative 4 and positive 4 eliminate each other. Positive 8 and positive 2 make 10y. Negative 12 and negative 3 make negative 15z. And negative 44 and positive 4 make negative 40. This is going to be your new row 2. So when I go to rewrite my system of equations, I will leave equation 1 the way it is with 3 terms. And my new row 2 is going to be 10y minus 15z equals negative 40. Notice that your x term is missing, and this is what you want. Now you need to repeat this procedure, but you need to do it now for the third row. So now I'm going to take row 1, and I'm going to times row 1 by a negative 3, which will give me negative 3x plus 6y minus 9z equals negative 33. And I'm going to add this to equation 3. 3x plus 3y minus z equals 4. When I add those together, notice that your x's eliminate again, and you are left with 9y minus 10z equals negative 37. This equation is going to be my new row 3. So, if you look at the Gaussian elimination that I presented you with on the first slide, you've currently eliminated both of your x's. But remember that the next task was not to just eliminate your x's, but it was also to eliminate the y in equation 3. So we need to get that 9y to go away. So the way we're going to get the 9y to eliminate is by dealing with equations 2 and 3. So I'm going to leave equation 1 alone, and if you want, you can recopy it if you need to. Equation 1 is going to stay, and equation 2 is going to stay. The one that needs altered is equation 3, because I need to make that 9y go away. So to do that, I'm going to go back over, and I'm going to deal with the two equations that involve y's and z's. So I have that 10y minus 15z equals negative 40, and 9y minus 10z equals negative 37. Now, this is great, but what I want to have happen is I want to get my y's to eliminate. So in order to make that happen, I'm going to have to multiply. And I'm going to multiply the top equation by a negative 9 and the bottom equation by a positive 10. So let's go ahead and do that. Negative 9 times 10 is going to be negative 90y. Negative 9 times negative 15 is positive 135z. Negative 9 times negative 40 is positive 360. Positive 10 times 9 is 90y. Positive 10 times negative 10 is negative 100z. And positive 10 times negative 37 is negative 370. Oh, I just realized that I had a mistake previously. Negative 33 plus 4 is negative 29. Sorry about that. So 10 times 29 is negative 290. So now I can add these two equations together. Negative 90 and positive 90 cancel. Positive 135 and negative 100 make 35z. 360 and negative 290 make 70. And this can now become my new row 3. Now that you have the form that was recommended with Gaussian elimination, you can now solve the system. So, I like to write all three of them next to each other. Equation 1, equation 2, and equation 3. Equation 3 only has one variable, so you can solve for z by dividing each side by 35, and your z is 2. Then you can take that result over to equation 2 and substitute it in. Negative 15 times 2 is negative 30. Subtract or add 30 to each side, and 10y is negative 10. Divide each side by 10, and y is negative 1. Then you can take both of those results over to equation 1 and substitute them in. Substitute the negative 1 in for y, and the 2 in for z. Negative 2 times negative 1 is positive 2. 3 times 2 is 6. Combine your like terms. Subtract 8 from both sides, and you get an x value of 3. Now your final answer needs to be written in the form of an ordered triple. So your final answer has to have the x first, the y second, and the z third. So my answer will be 3, negative 1, 2. I want to show you one more system because sometimes the systems do not work out to be an ordered triple, and sometimes you can get a no solution and you can get an infinite solution. This is going to be an example of an infinite solution. So we're going to start the process the same way as we did before. We want to try to get the 3x in equation 2 and the 1x in equation 3 to eliminate. So I'm going to leave equation 1 alone. As I write my system, that's just going to stay x plus y plus z equals 7. Now what I'm going to do is I'm going to pair equation 1 and 2 together, and I'm going to get my x's to eliminate. So to do that, I need to multiply equation 1 by negative 3. So I'll have a negative 3x, a negative 3y, a negative 3z equals a negative 21. And I need to add that to equation 2. Positive 3x minus 2y plus 1z equals 3. When I add those two equations together, my x's eliminate, which leaves me with minus 5y minus 2z equals minus 18. That can be my new row 2. Now I need to figure out row 3. So I need to pair equation 1 and equation 2 together. And I'm going to multiply equation 1 by negative 1. That'll give me negative 1x, negative 1y, negative 1z equals negative 7. Equation 3 does not need to be multiplied, so I have 1x plus 6y plus 3z equals 25. I'm going to add these two equations together, which will eliminate my x's and leave me with 5y plus 2z equals 18. That's my new row 3. Now, when you continue on with the problem, your next goal is to try to get the 5y in the bottom equation to eliminate. So in order to do that, you are allowed to add row 2 and row 3 together. So if I add those together, I am going to leave my row 1, x plus y plus z equals 7. I will leave row 2, negative 5y minus 2z equals negative 18. And then I will add row 2 and row 3 together. So negative 5y and positive 5y eliminate. Negative 2z and positive 2z eliminate, which leaves you with nothing on the left-hand side. Negative 18 and positive 18 eliminate, which leaves you nothing on the right-hand side. Whenever this happens, this means that you have infinite solutions. You can't just stop there, though. You have to actually write the answer as an ordered triple, which can get a little interesting. So I'm going to make some room over here so that you can see what this looks like. Okay, so when you go to write your ordered triple, you need to come up with an expression for x, y, and z. In general, the expression is going to be dependent on one of the variables. I personally like to make the expression dependent on z. So I have the third term just stay as a z. Then what I do is I take my second equation, my negative 5y minus 2z equals negative 18, and I solve it for y. So to do that, I need to add the 2z to the other side, and I need to divide every number by negative 5. And now I have an expression for y in terms of z. So for my middle term, I can put negative 2/5 x plus 18/5. You're not done though yet, because you need to also find an expression for x. So let's find our expression for x. So to get our expression for x, we start with our first equation. X plus y plus z is 7. And I'm going to replace the y with what I just found, which was negative negative 2/5 z plus 18/5. That's my y. Then I have the additional plus z equals 7. So you can combine your like terms. I can take the negative 2/5 z plus 1z. If I do that, I'm going to get a 3/5 z. And I need to solve for x. So I need to subtract the 18/5 to the other side. I also need to subtract the 3/5 z to the other side. And this will leave you with your expression of x. X equals negative 3/5 z plus, use your calculator to add 7 minus 18/5, 17/5. And that will be the first term in my ordered pair. So when you have infinite solutions, they do expect you to still write an ordered triple. Just so you know, you can still have the occasion where you get no solution. And just so you know what that's going to look like, when you go to add your two equations together, you will end up with a 0 on one side and a number on the other side that does not equal. If you ever see that, that means you have no solution. Last example for today is a story problem. In the story problems, you have to write your equations and you have to solve your equations. So, Lewis inherited $15,000 and invested part of it in a money market account, part in a municipal bond, and part in a mutual fund. You've just read your first equation. So the amount that went in the money market, I'll call that M for money market, and the amount that went in the municipal bond, and the amount that went in the mutual fund, added together is $15,000. Let's look at the next. After 1 year, he received a total of $730 in simple interest from the three investments. The money market paid 4%, the bonds paid 5%, and the mutual funds paid 6%. That is your next equation. So you made 4% on the mutual fund, you made 5% on the bonds, and you made 6% on the fund for a total of $730 in interest. Now you need one more equation. Your last equation says there was $2,000 more invested in the mutual fund than in the bonds. So if you were going to write that as an equation, your mutual funds equals the bonds plus $2,000. So if you were going to solve this, the first thing I would do is I would rearrange your equations so that they're all nice and lined up. So M plus B plus F is 15,000. Unless you really like percentages, I would consider multiplying the second equation by 100 so that you could get rid of all of the decimals. I think that's the easiest way to approach the problem, but it really is up to you. If you want to keep the decimals, that's fine. So I'm going to multiply this second equation by 100 to make the decimals go away, which is going to leave me with 4m plus 5b plus 6f equals 73,000. And then I'm going to reorder the second equation so that f and b are on the same side. So to do that, I'm going to have to subtract b to the left-hand side. So I will have minus 1b plus 1f equals 2,000. Now, if you're following the pattern, so far you're in really good shape because you have row 1 complete. And row 2, you're going to need to eliminate the 4m. So what we're going to do is we're going to take 4 times row 1 and we're going to add it to row 2. I'm going to not change the way my row 1 looks in the system. I'm only going to change it when I add it to row 2. So I'm going to take 4 times m negative 4 times m plus 4m, and that's going to eliminate the 4m from row 2. Negative 4 times b plus 5b is going to give me 1b. Negative 4 times f plus 6f is going to give me 2f. Negative 4 times 15,000, I believe is negative 60,000, but I'm going to check. Negative 4 times 15,000 is 60,000, negative 60,000. Plus 73,000 is 13,000. And then I'm going to just copy row 3. I have negative 1b and positive 1f equal to 2,000. Now, if I'm following Gaussian's elimination, I have row 1 complete and I have row 2 complete. So I'm just going to recopy those in my next line. M plus B plus F is 15,000. B plus 2F is 13,000. Now my goal is to get the B in row 3 to cancel. And I've noticed that the B in row 2 and the B in row 3 are opposites. So all I have to do is take row 2 plus row 3 and add them together. So positive B and negative B cancel. Positive 2 plus positive 1 makes 3F. Positive 13,000 and positive 2,000 makes positive 15,000. So I'm now prepared to solve my system. I'm going to start with the third equation. 3F equals 15,000. Divide each side by 3, which means I invested $5,000 in mutual funds. Then I'm going to take my result from that and substitute into equation 2, B plus 2F. I can substitute the 5,000 into that equation. 2 times 5,000 is 10,000. I can subtract the 10,000 from each side, and the amount I invested in bonds is 3,000. Last, I can substitute both of those numbers into the first equation. M plus B plus F is 15,000. So if I combine like terms, M plus 8,000 is 15,000. And if I subtract the 8,000 from each side, the amount in the money market is $7,000. Okay guys, hopefully this gets you started on this section. And next class I'll show you another approach for doing this with matrices.